NEC section 300.5d states that armored cable shall not be used where exposed to severe physical damage unless protected by raceways or other means. NEC section 392.10 states CLX cable shall be installed in accordance with NEC section 300.5 for type MC cable. It's important to consider whether the CLX cable is exposed to severe physical damage. If it is, NEC section 300.5d mandates protection through raceways or similar methods. Strapping the CLX cable armor and pulling individual conductors into a conduit is generally not recommended for several reasons. Firstly, loss of cable integrity. Removing the armor compromises the CLX cable's overall structure and reduces its resistance to physical damage. Secondly, grounding compromise. CLX cable typically incorporates a bare conductor bonded to the armor, which serves as a ground path. Stripping the armor disrupts this vital ground connection. Thirdly, lack of protection. The individual conductors are now exposed, leaving them susceptible to damage without the CLX armor's inherent protection. To ensure code compliance and maintain the electrical system's integrity, consider these approaches. Firstly, install the CLX cable fully protected within a conduit system as per NEC section 300.5 for type MC cable. This provides necessary mechanical protection and maintains the grounding integrity of the cable assembly. Secondly, terminate the CLX cable connector in the pull box and run a separate 1/0 ground conductor through the rest of the conduit, following the guidance in NEC section 310.4. The practice of stripping the CLX cable and pulling the conductors through conduit raises several code and safety concerns. The removal of the armor compromises the cable's physical protection and disrupts its intended grounding path. The individual conductors now exposed are more vulnerable to damage. Code compliance demands a holistic approach to maintaining cable integrity and grounding. It is advisable to use a full CLX cable within a conduit system, ensuring mechanical protection and a continuous grounding path. Terminating the CLX cable in the pull box and running a separate ground conductor offers another valid solution, provided it aligns with NEC regulations for conductor sizing and grounding. When dealing with electrical installations, always prioritize safety and adherence to the prevailing electrical codes. It's important to ensure the system is robust, reliable, and safe for personnel and equipment. If the CLX cable is exposed to potential physical damage, installing it within a conduit system is a proactive step towards safeguarding the installation. This added layer of protection minimizes the risk of damage to the cable and its conductors, which could lead to electrical faults, short circuits, or even fire hazards. The grounding conductor within a CLX cable is intentionally designed to provide a low impedance path for fault currents. This feature is critical for the proper operation of overcurrent protection devices, such as circuit breakers or fuses, which are designed to quickly interrupt the flow of electricity in the event of a fault. By maintaining the integrity of the grounding path, you enhance the effectiveness of these protective devices, contributing to a safer electrical system. NEC section 310.4 offers guidance on conductor sizing and installation requirements. Ensuring that the ground conductor is adequately sized and properly installed is essential for its ability to carry fault currents safely. When a fault occurs, a properly sized grounding conductor helps to quickly clear the fault, minimizing the potential for damaged equipment or injury to personnel. In addition to protecting against electrical faults, a well-designed grounding system also helps to minimize electrical noise and interference. This is particularly important in sensitive electronic equipment, where electrical noise can disrupt the proper operation of the equipment. A solid grounding system provides a stable reference point for electrical signals, reducing the impact of noise and interference. The choice between using the CLX cable's internal grounding conductor and running a separate ground conductor depends on a variety of factors, including the specific installation requirements, the size of the conductors, and the type of equipment being served. In some cases, it may be permissible to use the CLX cable's internal grounding conductor, provided that it meets the NEC requirements for conductor sizing and grounding impedance. In other cases, it may be necessary to run a separate ground conductor to ensure that the grounding system is adequate. When making this decision, it's essential to consult with a qualified electrical engineer or electrician to ensure that the grounding system is designed and installed in accordance with all applicable codes and standards. Remember that grounding is not just about protecting equipment, it's also about protecting people. A properly designed and installed grounding system can help to prevent electrical shock hazards, ensuring that people can safely interact with electrical equipment. It is imperative to always adhere to local electrical codes and regulations, which are designed to ensure the safety of electrical installations. Additionally, consulting with a qualified electrical professional is always recommended to ensure compliance and safety. Electrical codes are regularly updated to reflect the latest advancements in technology and safety practices. Staying informed about these changes is essential for maintaining a safe and compliant electrical system. Electrical work should always be performed by qualified and licensed professionals who have the necessary training and experience to perform the work safely and correctly. Attempting to perform electrical work without the proper knowledge and skills can be dangerous and may result in serious injury or property damage. A thorough inspection of the electrical system should be conducted periodically to identify any potential problems or safety hazards. This inspection should be performed by a qualified electrical professional who can identify and address any issues before they become serious. Proper maintenance of the electrical system is essential for ensuring its continued safety and reliability. This includes regularly inspecting and testing electrical equipment, replacing worn or damaged components, and keeping the system clean and free of debris. Electrical safety is everyone's responsibility. By taking the necessary precautions and following the guidelines outlined in this discussion, you can help to create a safer environment for yourself, your family, and your community. Always be aware of the potential hazards associated with electricity and never take shortcuts or compromise safety in any way. Electricity is a powerful force that should be treated with respect and caution. By following these best practices, you can minimize the risks associated with electricity and ensure a safe and reliable electrical system. In a specific scenario presented, stripping the CLX cable and running the individual conductors through conduit introduces several areas of concern. The NEC addresses the appropriate use of armored cables and their protection. If the CLX cable is susceptible to physical damage, it needs proper protection as specified in NEC section 300.5d. Stripping the cable negates the design protection. Moreover, the grounding scheme of the CLX cable is engineered as a complete system. When you remove the armor, you potentially interrupt the ground fault current path, which is crucial for safety. It may not be adequate to simply rely on the individual ground wires within the cable without maintaining the armor's contribution to grounding. In cases where CLX cable is run in conduit, the conduit itself can serve as an equipment grounding conductor under certain conditions outlined in the NEC. However, it's important to ensure that the conduit is properly installed and connected to provide a reliable grounding path. Simply running individual conductors through a conduit may not automatically satisfy grounding requirements. NEC section 310.4 addresses general requirements for conductors. It's not solely about the ampacity of the conductors, but also about their suitability for the application. Stripping the CLX cable alters the cable's listed characteristics, which could affect its suitability. When considering a solution, there are a few options. Firstly, run the entire CLX cable within the conduit. This maintains the cable's integrity and grounding system as designed. Ensure the conduit provides adequate physical protection and is properly grounded. Secondly, transition from the CLX cable to individual conductors in a junction box. In this case, terminate the CLX cable properly, bonding the cable's grounding conductor to the junction box. Then, run appropriately sized conductors from the junction box through the conduit to the equipment. The ground wire run with these conductors must meet the NEC requirements for equipment grounding conductors based on the overcurrent protection device. Thirdly, use a cable gland or connector listed for CLX cable to transition to the conduit system. This provides a secure connection and maintains the grounding path. Run the individual conductors through the conduit, ensuring they are properly sized and rated for the application. The equipment grounding conductor must also be appropriately sized. Regardless of the solution chosen, ensure that all connections are properly made and torqued to the manufacturer's specifications. Loose connections can lead to overheating and potential hazards. In the pull box, use appropriate connectors and bonding jumpers to maintain a continuous grounding path. The pull box itself must be properly grounded. When running conductors through conduit, use the correct fill percentages as specified in the NEC. Overfilling the conduit can make it difficult to pull conductors and can damage the insulation. Use pulling lubricant to reduce friction and prevent damage to the conductor's insulation. This is especially important for long runs or multiple bends. After the installation is complete, perform a thorough inspection to ensure that all connections are secure, the grounding system is intact, and the installation complies with all applicable codes and standards. This may include testing the grounding impedance to verify its effectiveness. Electrical work can be dangerous, and it's essential to take all necessary precautions to protect yourself and others. Work to energize whenever possible. Use appropriate personal protective equipment, such as gloves and eye protection. Follow lockout/tagout procedures to prevent accidental energization of the circuit. If you are not qualified to perform electrical work, hire a licensed electrician to do the job.